Okay, welcome back. Once again, the ANOVA F-test in simple linear regression is just given at the top of page 4 just for review. You might remember that we had two different tests for an association between the predictor and response in simple linear regression. And at the very end, we kind of said, well, why two tests for the same thing? Why even bother? And we said that we were just kind of setting ourselves up for multiple regression because now those two tests are going to be different. And so in multiple regression, the ANOVA table is exactly the same, except for degrees of freedom, which for the model are going to be the number of parameters in our model minus 1. For residuals are going to be the number of observations minus the number of parameters. And for the total, they're the same. But everything else is identical. Even the model formulas for these are the same. So sum of squares model is still the sum of our predicted response minus the overall mean squared for each observation. So formulas are exactly the same. When you get that predicted response, you're using more than one predictor, but other than that, no real changes here. You could also notice that when p equals 2 in the case of simple linear regression, when we just have an intercept and one slope, it reduces to the table up here, which should make sense. All right, and so just one quick typo that p is not the number of parameters, or not the number of predictors in our model, it's the number of parameters. And so remember, p includes the intercept. All right, so let's go ahead and write out the hypotheses that this ANOVA F-test ends up comparing in multiple regression. And so the null hypothesis is that none of the predictors are associated with the response. And what that means is the beta coefficients for all of the predictors are going to be equal to 0. So none of the predictors are associated with the response. Because this is the null hypothesis, sometimes this is called the global F-test or an overall F-test because it's testing to see if any of our predictors are useful for predicting the response or are associated with the response. We could also write, I'll kind of do it over here a little bit, the model under the null like we did before. And so in this case, the model under the null would plug in zeros for all these coefficients, so it would just be the constant mean model. The alternative hypothesis is that at least one of the beta coefficients is different than 0. And so this overall F-test is just testing to see if something is associated with the response in our model. The model under the alternative is we don't really know. So keep in mind that this overall F-test doesn't specify which betas are different than 0. So all it does is if we find if we get a small p-value for this test, we just know that at least one of our predictors are associated with the response, but we don't know if it's just one or if it's all of them or if it's a couple of them and we don't know which ones. And so this test is really best seen as just this kind of overall thing that we would tend to look at first just to see if any of our predictors are associated with the response, because if the answer to that is no, then we would kind of just stop there. Our conclusion for this test might be something like there is however much evidence that at least one of the predictors is associated with the response. And we'd give our f-stat, and we'd give our p-value. All right, so these bullet points kind of recap stuff that we've already talked about, but this third one is the most important. The test doesn't tell us which predictors or whether there's just one or two or all of them. It just tells us that at least one predictor is associated with the response. I think that this test overall should kind of hopefully leave you a little bit unsatisfied, and that if you actually run this test and you do find evidence that at least one of the predictors is associated with the response, that's not really that helpful of information, right? Like, it's not super useful to have that. I guess it's kind of nice to know if you find that there's no evidence that at least one of the predictors is associated with the response, because then you know that nothing in your model is really that useful, or at least that there's no evidence that anything in your model is useful. But the general, I think, the natural feeling toward this test is that it's not going to be super cool or super helpful to explain. We'll dive into next tests on individual predictors, which I think are generally a little bit more interesting, because you could say you can make a particular conclusion about one of the predictors in your model, and so it gives it a little bit more focus. And so we'll jump into that in the next video.